Hello 108 students, Mr. McHugh with you on section 8.3. I'm going to take care of page 3. Oops. And we're going to start off with objective 4. And now our challenge is this: what are you going to do if they ask you to multiply and the index numbers are not the same? The square root of 7 times the cube root of 2. Not the same. What are you supposed to do? Okay, so there's two key components to doing this. First thing is you got to convert these back to use your right hand L rule. I'm going to call it, rotate these up, convert them to exponents. So square root of 7 is 7 raised to the 1/2 power times 2 raised to the 1/3. Okay, now you first think, oh yeah. Excuse me, when I'm going to multiply the exponents, so then you got to put the brakes on because look, you've got different bases. Okay, now the trick now here is to convert 1/2 and 1/6 into the same fraction. I know this is a little unconventional. Think of like you're adding them, but you need to get the same denominator. You need the same denominator because when you get the same denominator, it's going to be the same index. And you can look down here. I'm going to go to the 6. So I convert 1/2 into 3/6. I convert 1/3 into 2/6. Okay. Now that I've done that, now I'm allowed to reconvert back into radical form mode, but this time the denominator becomes the index and I've got the same index. That's a key step in the process. Now that I've got the same index, what are you allowed to do underneath the radical signs, aka the radicand? Yes, you're allowed to multiply them. So I'm taking 7 cubed, which is 343, times 2 squared is 4. 4 times 343 is 1372, and I am taking the the 6th root of it. Okay, so those are a little I don't know, a little tricky here. Get a couple of them on the homework here. You got to think of converting into exponents and then getting the same exponents with the same LCD, and then convert back to radical. And then once you've got the same index number, like I said, the 6's, you now are multiply underneath the radicals. And there you go. Okay, now example 5 here, Pythagorean theorem. This is just a quick review. That it says that first you have a right triangle. You've got 2 legs, leg A, leg B, and the hypotenuse is always the side opposite the 90 degrees. You must identify the hypotenuse. Okay, Pythagorean was the famous Greek mathematician. He gets credit for this. I think the Egyptians were using it from what I've read. So it's been around. And what it allows you to do is measure the distance of any side. But I'm looking at the hypotenuse here because we're going to do the distance formula here. So the distance from this point to this point on the hypotenuse of the triangle, we're going to figure out here on example objective 6. But before we do that, I'm going to do a quick warm-up problem here where, given a Pythagorean theorem, it says the sum of the legs squared equals the hypotenuse squared. A lot of you probably remember, or you might say the hypotenuse squared equals the first leg 1 squared plus leg 2 squared. Okay, or you can remember it the way I have it here. The book says c squared equals a squared plus b squared. Hey, can you flip it around and say a squared plus b squared equals c squared? First leg squared plus the second leg squared equals the hypotenuse. Okay, so get those words in there. They turn around. Here's an example. They say one leg is length of 4. Another leg is length of 6. What would be the hypotenuse? What's the distance on the side? The side opposite the 90 degrees. Okay, so you start plug and chug away. C squared is what you're going to find. First leg is 4, you square it. Second leg is 6, you square it. 16 plus 36 is 52. Now, how do you isolate the C? Take the square root on both sides. Square root of C squared produces C. Square root of 52 can be broken down into 4 times 13. Don't go to your calculator. Okay, you got to find that perfect square because the square root of 4 is 2 and the square root of 13. This is a more precise answer than what you'd get on your calculator because it will be because the square root of 13 is an irrational number. Okay, now example 6, I am going to do a bonus page here. The distance formula, this is kind of important. You might see this in the final, you might see this on the test. I want to give us a little more foundation to it here. So this is example, actually it's example 9, and I'm going to do this on my next page here. I've got it in my class notes but not on yours, so I'm going to do it on a clean page. Okay, the distance formula is a special variation of the Pythagorean theorem. Given 2 points on a Cartesian coordinate plane, x1, y1, comma x2, y2, you can find the distance by finding the x-axis is the horizontal distance and the vertical distance. You're going to square the two of them, and that will equal the hypotenuse, HYP squared. That's what D stands for, the distance, but it's really the hypotenuse. Okay, so don't let the letters all mesh up there, but that's what we're going to do. Okay, Mr. McHugh, I'm going to check off here real quick. I will see you for the bonus page 4 of the videos here. I'm going to work on example 9. Okay, I'll see you then. Bye-bye.